Hello everyone, this is the problem of the week solution video for April 16th, 2021's problem. Excuse my pronunciation, I think it's pronounced Sibice, which is Croatian for matches. So anyway, let's get on to reading this problem and reviewing an example solution. Young Mirko threw matches all over the floor of his room. His mom did not like that and ordered him to put all the matches in a box. Mirko soon noticed that not all of the matches on the floor fit in the box, so he decided to take the matches that don't fit and throw them in the neighbor's garage, where his mom hopefully won't find them. Help Mirko determine which of the matches fit in the box his mom gave him. A match fits in the box if its entire length can lie on the bottom of the box. Mirko examines the matches one by one. Our input, the first line of input contains an integer n, where 1 is less than or equal to n is less than or equal to 50, the number of matches on the floor, and two integers w and h, the dimension of the box, where 1 is less than or equal to w is less than or equal to 100, where the same applies to the height as well. Each of the following n lines contains a single integer between 1 and 1000, which is inclusive, which is the length of one match. As for our output, for each match in the order they were given in the input, output on a separate line dA if the match fits in the box, or NE if it does not. Okay, so we're being asked to tell if the match will fit in the box or not, given its width or length. Let's tab over real quick to Microsoft Paint, where I've attempted to redraw something that kind of represents the problem. Here in black is the match box with the dimensions W and H, which is our width and height. Remember in the problem, the match doesn't just have to fit in the longest side, Mirko can lay it diagonally in the box, like shown in red. We need to figure out what that distance is. Luckily, this is just a rectangle, and the match cuts it in half, forming a triangle. So we can use the Pythagorean theorem to figure it out, shown in the bottom right there. So let's go over to the code to see an example implementation. The first thing we do here is to take our initial inputs, so the number of test cases, the width, and the height. The next thing we do here on line 5 is to find that hypotenuse of the match, the diagonal that limits the length of the match and thus determines whether it's going to fit or not. In here, we also cast the width and the height to an integer because it comes from a string from the input line. Note that when you do use the exponent operator, the numbers are implicitly typecast to a floating point number in Python. And this equation in line 5 is the exact same as the equation that was shown a minute ago. One more thing, keep in mind that square root is the same as putting something to the 1/2 power. The next thing we do is we iterate through this loop the integer representation of n times to run through all the match sizes that are given. If the integer representation of the input is greater than the number we calculated on line 5, then we print out NE, otherwise we'll print out DA. That's actually it for the code, so let's run the test cases that they give. Our first test case is 5, 3, 4, and then on separate lines 3, 4, 5, 6, 7. And that should return DA for the first 3 and NE for the last 2. Alright, so it's performing as expected. We have one more. Our second test case is 2, 12, 17, and then on separate lines 21 and 20. That should return NE for the first one and DA for the second one. There we go. Okay, that will be it for this video. Thank you.